Today we'll talk about the second part of chapter 15. This lecture we started in the last class, and we talked about the Pythagorean theorem, and using the Pythagorean theorem we can find one side of a right triangle given the other two sides known. Now we will look at some trigonometric functions today. Now these functions are also useful. In some cases they are more useful than Pythagorean theorem because these functions will help you to find one side when only one side is given. Remember we talked in the last class that the Pythagorean theorem you will be able to find one side when the other two sides are given. But using the trigonometric functions, you will be able to find one side when only one other side is given. So you will be able to find the similar. For an example, the side, but with the less information, right? Now let's again remember here, before we start discussing, all these trigonometric functions are applied to right triangle. Anytime you talk about triangle, that means right triangle here. Okay. So again, so some of the previous concepts, we know the side C is the hypotenuse, which is the opposite of the right angle, and there is an angle which is called theta. So for an example, theta can be A or B. In this picture, the theta is A, but it can be B as well. So the side B is called the adjacent side in this case. So the adjacent side is the side which is a side intersecting with C and B, and the theta is here. So that means if you see the theta here, then the B must be the adjacent side and A is the opposite side. So at this point, by opposite we mean the opposite to the theta. Okay, so opposite to the angle, because anytime after this slide if we mention angle, that means we are talking about the theta. So adjacent side means the side which is adjacent to the theta, and the other side you have is called the opposite side because that is just at the opposite of theta. Okay, and the other side, the longest side, is hypotenuse. Now these are the three sides we have in our right triangle. So now you see we have a same triangle, but the orientation is different. We just want to make sure that we understand the orientation. Now look at this A. The A is a different corner and the theta is here now. So this time this is going to be your small b is going to be your adjacent side. You see we moved the small b, okay, and small a is your opposite side. Do you see this is the opposite side right now because the theta is this one and this is the adjacent side. So be careful about that because adjacent side and opposite side are contextual and they are dependent on where your theta is. Okay, so if we understand it, I think we will be able to find it in every single right triangle. So these are some different orientations of right triangles, just to make sure we understand that all of these are right triangles. They have different orientations, and based on their orientations and based on the theta, the opposite side and adjacent side is different. Now here, let's say for the first one, the small b is the adjacent side and small a is your opposite side, right? This one, this is your opposite side, this is your adjacent side. Number 3, small b is this one, this is your adjacent side and this is your opposite side. Here this is your hypotenuse, this is your adjacent side, this is the opposite side. Here, this is your opposite side, this is your adjacent side. So be careful, all the adjacent sides and opposite sides are based on the theta. Let's try some quiz. In a right triangle, the opposite side of the 90-degree angle is called what? Of course, the hypotenuse, and that is the largest side of the right triangle. Opposite side of 90 degree. Right triangle shown, small a is, what is a small a? This must be the opposite to the angle A, right? Because you see the right small a is here, but the theta is here. It's just opposite. So be careful. Just look at the theta and then decide which side is the opposite side and which side is the adjacent side. These two sides and recognizing these two sides are really important when you will be talking about trigonometric functions, and you will be able to apply it. How about the b, small b? Look at that carefully. A small b. So are you choosing the answer number 1, A? Look at this. What is written? Adjacent to angle B. Is it adjacent to angle B? So small b is opposite to angle B. Be careful. So the right answer is B here. So the question can be extremely tricky because at this point we are talking about the angle B. We are not talking about the theta. But in general, by angle we mean theta. But if we mention the angle is B, we know that's B. That's not theta. Okay. All right. So how about this one? Small b is what? It's adjacent to angle A, right? So the right answer is small a. I'm sorry, right answer is A. So it's adjacent to A, right? Because you see small b, your small b is here. So, no. This is the right answer. Adjacent to angle A. So this angle here is adjacent to this side here, small b, is adjacent to angle A. How about small c? Is the hypotenuse, right? Which is easy to recognize because that's the largest side and that's the opposite to the 90-degree angle. Angle C. It must be 90 degree. That's the right angle of the right triangle. In the right triangle shown, which is the hypotenuse? Which C?
D.
So that remember is capital D. Right answer is D here because we denote the side by small letters, lowercase letters. So that's why it's not capital C, it's lowercase c. Because that is a side. Okay. In this right triangle, which is the hypotenuse? 1, 2, 3. There are 3 sides. Number 3, right? So the right answer is B. Which is the 90-degree angle here? Angle.
Oh, the 90-degree angle.
That must be Z. Right answer is a small a, right? I'm sorry, it's A. In right triangle, which is the side adjacent to X?
No. 2.
It must be 2, right? Because you see the angle X is here, and this is the adjacent side, this is the hypotenuse, and this must be the opposite side. Because we are talking about this angle. Whenever we are talking about X angle, C must be hypotenuse, number 2, the 3 must be hypotenuse, number 2 must be the adjacent side, and number 1 is the, so the right answer is B. Which side is the opposite side of angle x? Angle x. What is? It must be number 1. Right answer is A. Alright, now let's look at the trigonometric functions. Now there are several trigonometric functions. These are the first 3. There are 6 trigonometric functions we have. Now they are called sine, cosine and tangent. In short, we write sin for sine, we write cos for cosine, and we write tan for tangent. These are 3 different trigonometric functions. And interesting is they have some constant values which you can find using your calculator. You don't have to memorize any of those. You see here, those are some functions of the degrees. For an example, if you write sine 30, your calculator will give you 0.5. If you write sine 45, your calculator will give you 0.707. So these are some constant functions based on the angle. So these functions take degree as input and give you a constant number. And this number varies from 0 to 1 in general. You see, none of the numbers are less than 0 and none of the number here is larger than 0 between sine and cos. But the tan is different. You see, the tan has something which is larger than 1. So these are some functions, and you don't have to memorize anything. Just if you have a scientific calculator, just press cos, sine, you will see those buttons, and then sine, just type 45 and press equal, you will see this value. Okay, there is a, so we don't know exactly how to use it right now. We are just trying to look at the functions and just looking at how what kind of inputs the functions take and what are the outputs you are expecting. There are some inverse functions. They are also sine, cos, cosine and tangent, but we call them sine inverse or inverse sine, which is written sine to the power minus 1, something like this. Inverse cosine, cos to the power minus 1, inverse tangent, tan to the power minus 1. And these inverse functions take the constant number and give you the degrees. So it's just reverse way, because you know regular sine takes the degree and give you the constant number. Inverse function takes the constant number and gives you the degree. So again, you can just find all these inverse functions using the calculator. You don't have to memorize anything. Okay, we don't know yet how to use it or what are the purpose of these functions. We'll see it soon. So in general, your calculator is in degree mode. Okay, but if not, you can press the mode function. There you will see there is a mode button, and then when you go to mode, it will give you the option of selecting the degree. I know that you have different kinds of calculator, so if you want, you can just check your calculator and see whether you can find the degree mode. If you cannot, just let me know. I'll show you how to do it with your calculator, because you know there is no unique way of doing it, because each calculator has probably a little bit different way of doing, but it should be similar. If you have done it, because you know in general, but the default, if you even have not done it, the default must be in degree. If you have not changed it to something else. Can you find, using your calculator, can you find what is sine 30 degree? Everyone got C? Is this C for everyone? Alright, sine 25. Okay, make sure you understand how to use your calculator to find it. Okay, cosine 25. Everyone has a cosine 70 degree. Just to make sure we get familiar with these trigonometric functions and how to use it. B and D? B, okay, alright, it's B, 0.342. Tangent 70 degree. Everyone has C? So the right answer is C. Tangent 15. Right answer is A, right? 0.268. Now let's try some inverse functions. You will be still able to do it using your calculator. Check the inverse functions, trigonometric functions, inverse ones. So check whether you can find sine inverse 0.643. Inverse functions take constant numbers as input and gives you the degree. It's just in the reverse way. It gives you the degree, meaning whatever the result you get, that must be some degree, okay? The calculator will not show you the degree symbol, but you have to assume that that's a degree symbol. And I think we all know that how the degree symbols look like, right? That's a small bubble or a small just O, small ones, but use it as a superscript with your number. Everyone has the same degree. Sine inverse 0.985. Anyone has a different answer, just let me know, just to make sure we understand that you are doing it wrong. What is the right answer? C? Alright, let's try cosine inverse 0.766. What is the right answer? A? D? Everyone has A? Alright, so it's 40 degree. Yeah, the A was 40, so we move to the next question. Inverse cosine 0.819. Everyone has B? 35 degree. Tan inverse 0.176. D? Everyone has D? 9.98 degree. Alright. Tangent inverse 3.08. (72 degree). Now, let's dig a little bit more. So, as we know before that all these trigonometric functions are applied only to the right triangle. But remember, you can convert the obtuse or acute triangle to right triangle and then apply the formulas or trigonometric functions. For an example, if you look at the left triangle, you see that was originally an acute triangle, but when you draw this line, that became two separate right triangles, right? Now once you make it to right triangle, you can apply all the trigonometric functions for the left side, you can apply all the trigonometric functions for the right side, but you have to consider those as two separate right triangles. If you look at the bottom one, right side triangle, originally the yellow triangle is an obtuse triangle. You see this angle is more than 90 degree, but if you add some line like this, the black lines, you see that makes it right triangle. So since we know that all these trigonometric functions are only true for right triangles, you can tweak and twist the other triangles to make them right triangle, and then you can apply the functions or Pythagorean theorems, which one you need. Just to make sure we understand that It's possible. There is a possibility. Now, so far, we know how to get the sine, cosine, tangent, and their inverse functions, how to use those, or how to, I'm sorry, not how to use those, but how to get their values from the calculator. We know that. Now, you may wonder, how do you know how y sine 30 degree is 0.5? We don't know that, right? All these functions are basically some kind of ratios. Okay, for an example, any sine theta, where this is the theta, is the ratio of the length of the opposite side over the length of the hypotenuse. So that means this: if the theta is 30 degree for a right triangle, if the theta is 30 degree for a right triangle, then the ratio of opposite side and hypotenuse will be always 0.5. Doesn't matter how big or how small the triangle look like. Do you see what I'm saying? Is always 0.5. Doesn't matter how big or how small they look like. If the theta is 30 degree, it will be always 0.5. That's how we got those numbers. You see what I'm saying? Now, for an example, let's say the cosine theta is the ratio of the adjacent side and the hypotenuse. Now, if you look at cosine 60, you will see that cosine 60 is 0.5. Now, what does it mean? It means if the theta is 60 degree, then the ratio between adjacent side and hypotenuse will be always 0.5. That's how we got this number. If you check 1045, you see the tangent is the ratio between opposite side and adjacent side. If you just check 1045, you see the 1045 is 1. What does it mean? It means that if theta is 45 degree, then the ratio between opposite side and adjacent side is is 1, equal to 1. What does it mean? If the ratio of two things is 1, what does it mean? It means that they are same, they're equal. So that means whenever your theta is 45 degree, basically in any right triangle, adjacent side and opposite side will be equal. Doesn't matter how you draw it, how big or how small it is. And that's how we got those numbers. Now probably it should make a little bit more sense that, you know, the numbers are a little bit weird, right? 0.707. How do you get that? You get from these formulas. Alright, so to make it simple, instead of writing length of opposite side, we'll just go by opposite by hypotenuse. Remember, just to make it simple, okay? It's easy to just pronounce opposite over hypotenuse, but we know that we are dividing the length of opposite side by the length of hypotenuse to get the sine theta. Okay, all of these are length of. Okay, we just make it simple. So the sine theta is opposite by hypotenuse, cos theta is adjacent by hypotenuse, and tangent is opposite by adjacent. But remember, whenever you see all these ratios, be careful about your theta, because you know the theta is the angle which decides which is the adjacent side and which is the opposite side, right? Because if we change the theta from here to here, you know this is going to be your opposite side, the bottom one, and the other side is going to be, you know, those opposite sides and adjacent sides will be switched, right? So be careful about the theta, because you know theta will be changing your adjacent side and opposite side. Now these are all the ratios, and we just wanted to show you the inverse function as well, and see how you get these formulas. And we just tried to make it a little bit simple for you. Instead of writing opposite, we are writing OPP, stands for opposite, HYP, hypotenuse, ADJ for adjacent, just to use all the formulas. And we tried to write down all the formulas, and from the formulas we just modified the formulas to get all the angles, not angles, all the sides. For an example, let's say you want to find the hypotenuse, you know the opposite side. How to get that? Just apply this formula. So all these are basically the same formulas. All the three formulas we just modified it a little bit here and there. We just changed the side, and these are the exhaustive 9 formulas we have. Make sure we understand how to do this we understand how to do the trig functions, right? We just did that, right? How to get the sine theta or sine inverse, right? Now these are also the opposite, the inverse functions. We'll do some practice for sure, and let's try this question first. Let's say you are given an angle A. For the right triangle below, which substitutions are true? Now let's look at all the substitutions. Now here you are given a small a, that means the side, right, which is the opposite side. So remember, so in this case, angle A, the angle that is given to you, that must be theta, okay? In any question, if you see one angle is given, you know that one angle must be 90 degrees, so that doesn't matter, because you know nobody has to tell you that, okay, in right triangle one angle has to be 90 degrees, because you know it. The person who is giving the question, he knows it. So that's not the angle they will be giving you, okay? But they will tell you something else. One angle is 35 degrees. That means the angle they give you, that is your theta, okay? So you will assume that that angle must be theta. So let's say this is your theta right now. A is your theta. If A is your theta, what is a small a? It must be opposite, right? So let's say, so A is theta, you know, so a small a must be opposite. So that rules out option B and C, because in option B, A is adjacent, and that cannot be possible, right? In option C, A is hypotenuse. That's also impossible. So now we are reduced with only A and D. Now let's check small b. What is a small b here? That must be adjacent, right? So the right answer must be D then, because in option A, B is assumed as hypotenuse, which is impossible, right? Hypotenuse is a small c here. So the right answer must be D. Any confusion, make sure we understand it. Because you know, understanding the question is important. We are just trying to give you some hints so that you understand the question, and from the question you can figure out what is going to be your theta, what is your adjacent side, and what will be the opposite side, so that you can apply the trigonometric functions correctly. Let's look at a problem here. Let's say you are given a small a and a small c. Those are given in your question. For the right triangle below, which formula should you use to find angle A? Anytime, remember, when you are trying to find the angle, you have to use the inverse trigonometric functions, because inverse trigonometric functions give you the angle as an output. So that rules out A and D, because if you look at A and D, they are not inverse functions, right? But B and C are inverse functions, inverse trigonometric functions. So either B or C will be right. Now let's look at the right side. This looks like in the right side you will need, for B, option B, you will need a small a and a small c. Are you given a small a and a small c? You are, right? So that's your choice then. Because if you choose number C, in the right side, look at the tangent, inverse tangent, you will need a small a and a small b, whereas small b is not given in your question. You always remember that you have to find the unknown from the knowns. So what is known to you? What are known to you here is A, R, A and C. So that's why you have to use A and C here to get your capital A, which is the angle A. You see what I'm saying? So in each and every question you will solve, you will see all the formulas are given to you. Okay? But you have to pick which one is applied to this question. when you find the angle, you will be using inverse function, and in the right side you will make sure that which one is applied to your case given your information. Because C is not applied here because you don't know B, small b, but you know small a and a small c, which makes it simple, right? So just apply option B, you'll be done. And remember, for any problem, if you are given something, you should be able to use one of the trigonometric functions. We don't know exactly which one based on the question. Let's say for another one, you are given a small a and a small b, and you are trying to find angle A. Look at which formula you want to use. Everyone see? Look at the option C. You are finding angle A, and what you are using? Small a and a small b, and those are the two sides are given to you. So it must be the right choice. But if you choose B this time, you see, for B you need C. Small c is not given in your question. So just choose C. You'll be given all the formulas here, okay? And you can use these formulas, just replace the hypotenuse by C, opposite by B, adjacent by A, right? That's what we know. We always treat adjacent by A, small a, opposite by a small b, and adjacent by small c.
You mean angle, right?
No, side. Now how about this question? This time it's a little bit different. You are given side A and angle A, and you have to find small b. Which formula to use? Look at the A. You are finding B. On the right side, you need a small a and capital A. Both are given in your answer question, right? So you must be able to find your small a, side A, from option 1, which is option A. In any other option, you will need C, right? Which is not given to your question. We're just trying to practice which formula you need, where all the formulas are given to you. Let's try another question here. You are given a small b and angle B for the right triangle below. Which substitution you should use to find A? Now, how to assume what is what? Now, a small b and angle B is given. Now, this time, the angle B is given. That means angle B is going to be your theta. Any angle that is given to you except the right angle, that is your theta. So this is going to be your theta now. So automatically this is your opposite side, and this is your adjacent side. Okay. So which option you pick? B is theta for sure. A is not opposite. A is adjacent, right? And A is adjacent side, and B is your opposite side. So the right answer must be B. B is theta, A is adjacent, B is opposite. Small b. B cannot be hypotenuse, B cannot be adjacent, B cannot be adjacent here. So none other option will have all the three right choices. You are given a small b and angle B. You have to find small a, side A. Which formula to use? We have written the formula numbers. So 3, 6, 7, 8 are given out of all 9 formulas. 4 formulas are given in your answer. Which one to use? It must be A, right? Because in A you are trying to find the side A. In the right side you need side B and angle B, which are given in your question. See, the side B is given, angle B is given. So you need both of those. So your choice must be A, because you are trying to find a small a and you have a small a here. And try to match. Do you see that this is the formula number 8? This is the formula number 8. Can you find the match between 8 and this? This is the formula 8. Now how to know this is the formula 8? Look at this. Adjacent means A here. Why adjacent means A? Because your angle is B, right? When the angle is B, this must be the adjacent side, right? So that's why this is the small a. Now, opposite is B, right? Because since this is the angle, this must be the opposite, right? Opposite is B, and your tan theta is basically your theta is B here, right? Because this angle is given. Any angle that is given will be your theta, except 90-degree angle, because we know that one angle is 90 degree, and that's something will never be the angle. That is just right angle. We know that for sure. We will have it for any right triangle. You are given a small a and a small c. Which formula to use to find a small b? This time it must be D. Don't forget the Pythagorean theorem. This formula is the Pythagorean theorem, right? Remember we covered it in the last class. Because you are given two sides and you are trying to find the other side, you don't need anything else here, because any of this, if you look at the right side, you will need any angle. You will need angle A, and none of angle A is not given to you. Let's check this question. Angle A is 35 degree. Side A is 6 feet. Can you find 3 different items? First, angle B, side B, and side C. Now, how to find which formula to use? Can you tell us which formula to use to find the capital B here? Look at the list of the formulas. We also added 4 more formulas from the previous lecture. We added the 3 formulas from the Pythagorean, which are 10, 11, and 12. And we added one formula as 13, which is a trivial formula, because we know that in any triangle we have 180 degree, and in case of the right triangle, since one angle is 90 degree, other 2 angle must be 90 degree in total. So that's how angle A and angle B must be 90 degree. Now can you tell us, sometime you may have multiple choice, multiple options. You will have multiple formulas which can be used to have your answer. But we want to know which is the easiest. We always want to find the easiest route. What is the easiest formula to find the B? It must be formula number 13. Because when the formula number 13 is applied, one angle is 35 and other angle must be 55, right? 55 plus 35 is 90, right? So the angle B must be 55 then. I know that you'll be able to use the other one, but that's probably the easiest one we have. It must be 55. Now let's try. So now we know that B is 55. Now can you find side B or side C? Let's say to find C, we are trying to find the hypotenuse, right? C is your hypotenuse. Can anyone tell me which formula we can use? Look at the formula numbers. You are trying to find the side C. look at what you know. You know angle A, you know side A, you know angle B. Now remember, don't get confused. There are two angles you are given, right? But if we assume your angle is A, so A is going to be your theta. And you can apply similarly. You see what I'm saying? When you assume that A is your theta, so this is going to be your opposite and this is going to be your adjacent. Okay? But when you assume that B is your theta, because you know, either A or B can be theta. Now it's up to you which one you want to use. If you assume that B is a theta, so you assume the B is theta, so this is going to be your opposite side. And this is going to be your adjacent side. Now it's up to you whether you want to work with A or B. Because you know, based on A or B, your side and I'm saying your adjacent and opposite will be different, right? But you can either use A or B, it's up to you. You can use any of these. You are trying to find the hypotenuse. Now, first of all, just looking at the whole picture, just try to find, let me make it a little bit easier. Let's see in which formulas you are trying to find the hypotenuse, right? Which is C. Which formulas you have hypotenuse at your left side isolated? So formula number 2, you have hypotenuse at the left side isolated. Formula number 5, you have hypotenuse at the left side. And formula number 10, you have hypotenuse at your left side. So these are the possible options you have, either 2 or 5 or 10. Now let's check one at a time. If you look at 10, what is the problem? The problem is B is not given yet. You don't have B. Do you see that? So it's ruled out. So the 10 is gone. Now your choice is either 2 or 5. Now from 2 you will be able to find it, because whenever you think that theta is let's say you are given A, right? So this is your A. So if you assume that this is your theta, you will need the opposite which is given, right? If this is your theta, so this is the opposite which is given, and you will be able to use it. But if you use if you use number 5, formula number 5, you need the adjacent and theta. Now if you assume that this is your theta, so this is going to be adjacent, right? If you assume that B is your theta, so small a is going to be your adjacent side, which is also applied because you know the small a and you know the B as well. So the right answer is 2 and 5. Both can be used to find your hypotenuse. So the right answer is D here. Be careful. These questions are really important because you know it will teach you how to find your right formula. You had 3 options and one option was ruled out because you did not know the small b, so you cannot use the Pythagorean theorem here. Any question? Let's try another example. We are not done yet, so we'll continue this example now. Let's say we found the C, which is, let's say we are using, for an example, we are using formula number 2. You know, we can either use 2 or 5. Let's pick 2. We pick 2, so this is your formula, A over sine theta. Now, which theta you use? Now, since small a is here, look at this. Small a is considered as an opposite side, right? So if small a is the opposite, angle must be capital A, right? Which is 35. So be careful because you know sine 35 and sine 55 will have different constant. So if you apply it, what is going to be C? Can anyone help us to find it? A over sine 35 degree. 6 over, A is 6, right? 6 feet. 6 over sine 35. Is the right answer is C? Everyone has right answer C? 6 over sine 35. C, right? So the C is 10.5. Now we know the C. We added the, this is the list of our information we know. Now let's try to find a small b. Now tell us which formula to use. What are the possible options? You are trying to find a small b here. You are trying to find a small b. What is a good choice? These are all the formulas. Number 12, 3, 9, 6, and this tells you can use any of these. You can choose all of these formulas, 12, 3, 9, 6. So check the formula number 3, 6, 9, 12. Check all the formulas. 3, 6, 9, 12. Excuse me. Now let's look at 12 first. You must be able to use 12 because you know C and A, right? You know both C and A, so you must be able to use 12 for sure. Now how about 3 and 9? Now let's look at 3. You must be able to use 3 because you know that if you assume that B is an opposite side, you have to assume B is the opposite. Now if you assume that B is the opposite side, your angle must be capital B, right? Your angle must be capital B. So you will assume that angle is going to be 55, right? Yeah. You can either use A or B as your angle, just to keep track of that, because whenever you assume that B is the opposite, look at this, whenever you assume that a small b, side B is your opposite side, your angle must be capital B. Or if you assume that your side is a small a, your angle must be capital A. You just have to keep track of that. So since you are assuming that B is the opposite side, so your angle must be capital B, which is 55. So you have to apply 55 here. You are done. Now rule number 6, this time you assume that B is an adjacent side. If you assume that B is an adjacent side, what is going to be your angle? A, right? If A is the angle, B is the adjacent side. Now this time you will calculate like a small b equals to C times cosine what? 35, because angle A is 35. So the 3 and 6 both are working. How about 9? In case of 9, you will assume B as an opposite side, right? Because you are trying to find B. So A must be the adjacent side. Now if the A is adjacent and B is opposite, what is the angle? B is opposite. So the angle must be capital B. Look at this. If this is the opposite side, this must be the angle, right?
Oh, okay.
That's exactly what we are talking about here. So now your theta must be 55. Be careful about that, because in trigonometry, those opposite and adjacent side makes you confused, because whenever you are talking about one adjacent side, you have to think the theta like that. Okay, any side can be either used as an adjacent side or as an opposite side. The only difference will be if you just think it as an adjacent side, your angle will be something. If you think it as an opposite side, your angle will be something else. You see what I'm saying? But all these formulas 3, 6, 9, 12 can be applied. So the right answer is D. We are trying to show you that there are several options you can use. Now it's up to you which one you use. You can find the best one. For me, the best option is number 12. Look at the formula 12. Because b equals to c square minus a square square root, where c and a is given. A are given. You see, so the c is 10.5 feet and a is 6 feet. We know the length. Apply it, get it done. Smallest, easiest. But you should also know that 3, 6, and 9 are working. They also work for the same thing. Remember, so, and also be sure, doesn't matter which formula you use, you will get the same answer. If you use one formula and you get different result, that means you are doing something else. You are getting wrong answer, but the formulas cannot be wrong, but the only thing that can be wrong is how you are thinking your adjacent side and what angle you are considering. You have seen the example, right, that how the angles are changing based on what side is adjacent and what side is opposite. So, so let's say we pick formula number 8. Let's say we pick formula 8. Okay? And we got the b, small b. Because interesting is formula 8 also can be applied to find the adjacent b as an adjacent side. So use the formula b, we know the a, and this time since the b is an adjacent side, look at this, b is the adjacent side. What is going to be your angle? B is the adjacent side. What is the angle? What is the theta? Capital A, right? This is your angle since this is the adjacent side. So you have to think it backward. If B is the adjacent side, what is the angle? It must be capital A, right? So that's why whenever we are using this formula, because this is formula number 8, and if you look at here, in formula number 8, we are replacing the adjacent side by B. That means we are assuming that B is an adjacent side. So that means we have to consider the angle A as theta. So the theta is going to be 35. Once we do it, can anyone find the answer? A over 1035. A over 1035. What is the answer? And that will be B. I don't think that's 10.5. That will be little bit less than 10.5, I think. I think that must be close to 8.57. Check it. How much you get? Tangent. Yes, yeah. Which is option number C. Everyone has option number C? A over 1035. This looks like everyone has a different answer. We really appreciate if you have a different answer, but unfortunately the right answer is 8.57. A over 1035. Okay, now, so the right answer is 8.57, and that's it. So this is the end of chapter 15, and at the same time this is the end of the syllabus, because this was the last chapter we wanted to cover before the final, and after this class we will first spend time to finish all the homeworks of chapter 15. You see that, right? That if you just delay a little bit, you'll forget all the discussions we had in the class. So make sure you finish all the homeworks, the 3 homeworks from chapter 15 as soon as possible. And then we will go back to all the previous homeworks if we have any question, anything, because the final is going to be the comprehensive exam. So you have to finish all the homeworks and check whether you can make 100% in every single one so that you can get 25% out of 25 in your homework credit. That's still under your control because all the homeworks are still open. And then we'll review for the final. If you go to the quiz section in pause, you will see there are sample final already posted. So we'll practice the sample final until we have the final. So the remaining class, for the remaining weeks, we'll do all the practice sessions. Any question? So we have covered several chapters in this class. Can anyone have any chapter that you like most? How about chapter 15? All right, I think we can discuss it after we are done with the homework, right? Then probably we'll like it because after we are done with homework, you'll understand it better and then you will probably, now you're a little bit in. All right, so let's stop the lecture here. And anytime if you want to go back to the lecture, just go to the pause and go to the Tegrity lecture sessions and you will have all this lecture recorded with the voice.